In this video, I'm going to show you two scripts that are made completely for 3D printing. I've created the full length script and I've also turned it into a cluster, which is basically simplifying the inputs and outputs. And you can also double click on the cluster and open it up. So why this is useful, this is an articulated chain and all of the options are available here. So first things first is everything is fully parametric. So if we try to select this inside of Rhino, we can't because all of the options are here and we need to bake the chain to be able to see all of the options. So notice now that if I take this and I move this up, we have the mechanism that allows it to articulate. So it's basically this cone that overhangs, and this one has that cone taken away. So if I take a clipping plane and show it to you as a vertical, notice that now we can see here the tolerance between the two. And I do have a 3D printed version of it. Let's see if you can see this. And it articulates perfectly like this. This is a fairly small iteration, but I just wanted to test it to see if it works, and it does. So let me show you some of the options of the things that we can do within the script so you can see the extent of what this is. So the first thing is we can create an array, right, to extend the length of this. But I also added a set of dimensions so you can have an idea of the overall size of the chain. Then when we get here to the length, this is where we can change the overall design. So the length is going to be the length of this portion. So there's the length that determines this portion. And then there's the other one that determines the length of the other portion. So between these two, and notice that there's some limitations, like that went too far. Let's see if 5, let's see if 6. Now the width of it is going to be for this side and for this side the same. So it's actually multiplied by 2. So if I go here to 5, that's the length of this one. And then the width of this one is going to be for the center portion. Actually, this is for the length of that. And then this one is for the center one. Or this is the height. Let's do that again. 5 is too low. So we'll raise this to 6. The tolerance is going to be what allows us to articulate it. So if I go here and I turn this into a more of a wireframe, we can see that we have our tolerance here. And if we change this to 0.1, there's going to be a 0.1 tolerance. And this depends both on your preference of how much you want it to articulate and your printer, because some printers have different tolerances. Then the hinge size, that's the circle here. Notice that we can change how big that is. And I've made this so let's go to the hinge size. And I've made this so you can use it over and over again, depending on what you're trying to use it for. I've already created a watch that is 3D printed for my kids, and they liked it. So I'm just going here further and refining the script and making it available for everyone. So this overhangs by 1 millimeter to the inside. If we do 2, it overhangs further. But at some point, if you overhang it too far, then when you try to print it, this mechanism won't print correctly. So I try to keep it somewhere reasonable where the radius and the diameter of the circle does not exceed how much I extend it in terms of overhang. And now fillet, this is going to be how much we can round it off. And this is also has a limit, of course, because if you take it too far, notice that it doesn't work. But we can also do 0. But this gives it a nice clean look when you 3D print it. Lastly, the array, which is critical because I've created the spacing to be perfect. So they will line up and they'll be set up and ready to 3D print. So let's increase this. Let's take a look at the dimensions. 18.6, and that's because we have 6.8. So let's change it to 7 to keep it a clean dimension. And then actually 8. 7.5. So we have 20 and then 6 in this direction. I'll go to this and bake it. And I'll move it here to the side. So now that I've baked it, what I need to do is turn it into an STL. So instead of just exporting it as an STL, I like to turn it into a mesh. And the option that I use is smooth and slower, and just increase these sliders all the way up. And when you hit OK, it creates the mesh, but it overlaps with your existing. So I just move it to the side. And then this is what we're going to use. So let me use a clipping plane again here. So I want to see the mechanism. And so that is what that looks like in section. So you can see exactly how things intersect. So they start printing flat, and then this one caves in and this one overhangs. Okay. Now with this, I can take this and export it. So I'll select it and do File, Export Selected. And then in here, I can pick the location of where I want to save it, but I have to make sure it's under an STL. So as you can see, I'm saving it here as an STL. And now let's open it up in the slicer. So the slicer that I'm using is Elegoo slicer, but I think it's based off of Orca. I'll just go here to New Project and then drag the file in here. So let me look for this, drag and drop it. And now I'm just going to be using the defaults to slice it. And so this takes about 20 minutes, and I'm just using kind of the default settings here. And notice how that prints. So for those of you who are interested in seeing how parametric design works for 3D printing, I'll be having both this and the other script available on my website for free for a limited time. I'm doing this to share with those of you who are fairly new and don't know how it works, so you can download it and see how things plug in. And I also have other resources if you'd like to check those out. So thank you very much for being here. Hopefully you learned a little bit more on how 3D printing can take advantage of parametric tools like Grasshopper, and I hope to see you in the next one.